Right now, as you lie here, you're certain of one thing. You're not moving. The bed is still. The glass of water on the nightstand sits perfectly flat. Nothing pushes on you. But under that stillness, the floor is turning eastward faster than the sound of my voice could travel. The whole planet is falling around the sun at 67,000 miles an hour. The sun is dragging you around the galaxy at 500,000, and the entire galaxy is sweeping through the universe at more than 1,000,000 miles an hour toward a place you have never been shown. You're not lying still tonight. You're being carried faster than any machine humans have ever built, and your body has no idea. By the end of this, you will know your true speed through space and the strange, specific place you're being carried toward. Get comfortable. If you're the kind of person who finds it calming to have the words still quietly taken apart, a quick like and subscribe helps this channel reach more curious minds like you. Because by the end of tonight, lying perfectly still is going to feel like the strangest thing you do all day. Now, let's gently drift into this. Reach over to the nightstand and picture a glass of water sitting there in the dark. The surface is flat. It does not tremble. It does not lean toward one wall of the glass. It does not slosh. If you hold your hand out in front of you, it stays where you put it. The blanket has a certain weight, and that weight sits evenly on you, unmoving. Everything about this moment agrees on one thing, quietly and completely. You're not going anywhere. You're lying still in a still room on a still night, and nothing in your body has the slightest reason to doubt it. Hold on to that glass of water, because it is going to follow us all the way to the end of tonight. That flat, untroubled surface is the most honest instrument in the room, and it is about to become the strangest. By the time we're done, you will know that while it sat there looking perfectly level, it was being carried through the universe at a speed you would not have believed if I had led with the number, and the water still would not have spilled. That is the puzzle we're going to take apart, slowly, one layer at a time. Here is the question we are chasing, and it is the kind of question a child asks and a physicist spends a career learning to answer properly. How fast are we actually moving right now? Not the car, not the train, not the plane. You, lying in your bed, on the ground, on a night when you're doing absolutely nothing. The honest answer is going to change several times before the night is over, and each time it changes it will get larger and stranger, until the final answer stops being a number at all and turns into a direction, pointing at something we cannot see. But we have to start with the stillness, because the stillness is not a mistake. This is the first thing worth getting right, and most explanations skip past it. Your body is not failing to notice your motion. Your body is correctly reporting something true about the physics of movement, and the truth it is reporting is this. A perfectly smooth motion feels exactly like no motion at all. There is no experiment you can run, lying in that bed, that would tell you whether you're at rest or gliding along at a constant speed. The stillness you feel is not ignorance. It is a law. Think about the last time you were on a plane at cruising altitude. The seatbelt sign is off, the air is smooth, and you're moving over the ground at something like 500 miles an hour. If you close your eyes and the ride is calm enough, you cannot feel that speed. You could pour a drink. You could balance a coin on the tray table. The cabin around you does not betray, in any way your senses can reach, that you're crossing a mile of country every 7 or 8 seconds. The only moments you actually feel are the takeoff, the turbulence, the banking turn, the landing. In other words, you feel the changes. You never feel the speed itself. That distinction is everything, and it is worth saying slowly. You do not feel motion. You feel changes in motion. Speeding up, slowing down, turning, dropping, being pushed or pulled in a new direction. Physicists call those changes acceleration, and acceleration is the only thing your body has ever been able to sense. A steady, unchanging velocity produces no force on you whatsoever. It is, from the inside, indistinguishable from sitting perfectly still. So when you lie there tonight and feel like you're not moving, what your body is really telling you is narrower and more precise than it sounds. It is telling you that you're not accelerating. It is telling you nothing at all about how fast you're going. This idea is older than you might think, and it belongs to a man watching ships. 4 centuries ago, Galileo pointed out that if you were sealed in the windowless cabin of a ship moving smoothly across calm water, no experiment you performed inside could tell you the ship was moving. Drop a ball, and it falls straight to your feet, exactly as it would in a docked ship. Watch a fish swim in a bowl, or a drop of water fall from a jar, and everything behaves precisely as it would on solid ground. The physics inside the cabin is identical whether the ship is tied to the dock or gliding across the sea. There is no test for smooth motion from the inside. Centuries later, Einstein took this same simple observation and built it into the foundation of modern physics, sharpening it into a principle. There is no special, absolute state of rest that any experiment can detect. Motion, the steady kind, is always relative to something else. So the water in the glass sits flat not because the room is truly still, but because whatever motion the room has is smooth, shared by everything in it, and therefore invisible. That is your first clue. The stillness is real as a feeling and false as a fact, and both of those things are true at the same time. Tonight is going to live in that gap, the space between what your body reports and what the measurements say, and the gap is going to get wider than you can currently imagine. Let me give you the shape of where we're going, without spending the surprise. We're going to climb a ladder. Each rung is a real motion you're making at this very moment, and each rung is faster than the one below it. We will start with the gentlest, the turning of the ground beneath you, and we will climb through the fall of the whole planet around the sun, and then the plunge of the entire solar system around the heart of the galaxy. And when we reach the top of that ladder, we're going to hit a strange wall, a moment where the question how fast are we going seems to have no answer at all, for a reason built into the laws of physics themselves. And then, from that wall, we're going to find a door that almost no one expects, a way to measure our true speed against the universe as a whole. What is on the other side of that door is the reason this video exists. There is a piece of you built specifically to detect motion, and it is worth knowing what it actually measures. Deep inside each of your ears, behind the part that hears, sits a set of tiny fluid-filled loops and chambers called the vestibular system. It is your private motion sensor, the thing that tells you which way is up and whether you're turning or tipping. But look closely at what it responds to, and you find it only ever reacts to change. When an elevator starts to rise, you feel it in your stomach for a second, and then, as it settles into a steady climb, the feeling vanishes even though you're still moving upward. When it slows to stop, you feel it again. The sensor fires at the start and the stop, at every change, and goes quiet in between. It is not a speedometer. It is a change detector, and a smooth, unchanging motion, however fast, gives it nothing to report. You can test this against your own memory right now. Think of the smoothest, fastest ride you have ever taken. A high-speed train gliding at nearly 200 miles an hour, so steady that a coffee on the little tray sat perfectly flat, and you could read without the slightest trouble. A plane at cruising height, 500 miles an hour over a dark ocean, and you asleep against the window as though you were in your own bed. In every one of those cases, the faster and smoother the ride, the more completely it felt like stillness. That is not a coincidence or a quirk of comfortable seats. It is the same law showing itself over and over. Steady motion cannot be felt from the inside. The better a ride hides its speed, the more honest it is being about how motion actually works. So give our ancestors their due, because they were not being foolish. For almost the whole of human history, people looked around at a world that felt solid and unmoving, and concluded reasonably that the earth stood still while the heavens turned around it. Every sense they had agreed. The ground did not lurch. The water did not spill. Nothing pushed on them. They were running exactly the experiment Galileo would later describe, the sealed cabin with no window, and they were getting exactly the answer the experiment gives. No motion detected. It took centuries of careful thought and clever measurement to realize that no motion detected does not mean no motion. It means only that the motion, if there is any, is smooth and shared. And it is. It always was. This is why the question we are chasing tonight is harder and better than it first sounds. When I ask how fast you're moving, your body has already answered, confidently, not at all, and your body's not lying. It is giving the correct answer to a slightly different question, the question, am I accelerating? To get at the real speed, the one your senses can never reach, we're going to have to leave the evidence of the body behind and measure ourselves against things far larger than the room. And every time we do, the answer is going to jump. For now, stay with the stillness one more moment. Feel how total it is. Feel how completely convinced you are that you're not moving. That conviction is the thing we're going to dismantle gently, and the first crack in it is not in the sky or in some distant galaxy. It is in the floor directly beneath you, which is not holding still at all. It is turning, and it is turning faster than the sound of my voice could travel. Picture the sun rising, not the romantic version, but the literal mechanics of it. The sky goes from black to grey to gold, and the sun lifts off the horizon and climbs. It is the most ordinary sight there is, something every human who has ever lived has watched, and almost all of them believed the same reasonable wrong thing about it. They believed the sun was moving. It looks like the sun is climbing the sky, so surely the sun is the thing in motion, but the sun is not rising. You are. The sun is sitting almost exactly where it was. What is moving is the ground under your feet, rotating you around to face it, swinging the edge of the world down and out of the way so that a star which never moved comes into view. That rotation has a speed, and the speed is larger than people expect. The Earth turns once on its axis roughly every 24 hours. That sounds slow and stately, and at the scale of a single glance out the window it is. But the Earth is enormous. If you're standing near the equator, the ground beneath you has to travel all the way around the entire circumference of the planet, a distance of about 40,000 kilometers, and it has to do it in that same 24 hours. Work out what that requires, and you get a speed of roughly 1,670 kilometers an hour. In the older units, that is a little over 1,000 miles an hour. Let me put that number somewhere you can feel it, because a number alone is just a number. 1,670 kilometers an hour is faster than the speed of sound. Sound travels through the air at sea level at about 1,235 kilometers an hour. So a person standing on the equator, doing nothing, holding a cup of coffee, is being carried eastward faster than the sound of their own voice could travel through the air around them. If you could somehow leave a clap of thunder hanging in space and race the spinning ground against it, the ground would win. You are right now breaking the sound barrier in the most literal geometric sense, and the coffee is not even rippling. This is the second rung of our ladder, and already the gap between feeling and fact has opened wider. On the first rung, the stillness of the bed, the true speed was hidden, but at least the motion was smooth in the plainest way. Here you can actually name a mechanism, a spin, a great turning, and still you cannot feel a thing. Why not? For the same reason as before, with one small addition. The spin is smooth and shared, so there is no jolt to feel. But the spin also involves going in a circle, and going in a circle is a kind of acceleration, a constant gentle change in direction. So shouldn't you feel that? You should, and you do, just barely. And the reason it is so faint is worth pausing on. The turning of the Earth does produce a real outward effect, the same effect that presses you into your seat when a car takes a fast curve. But the Earth is so large and turns so slowly, relative to its size, that this effect at the equator is tiny. It amounts to about 0.03 of a meter per second squared, which is roughly 0.3 of 1% of the pull of gravity. In plain terms, the spin of the entire planet lightens you by about 0.33% compared to standing at the pole. It is there, it is measurable, it is utterly beneath your notice. You would need sensitive instruments to catch what your body simply shrugs off. Now notice where you are on the planet, because the spin is not the same speed everywhere. It is fastest at the equator, where the ground has the farthest to travel in a day. As you move toward the poles, the circle you're being carried around gets smaller, so the speed drops. At a latitude of 45 degrees, roughly the latitude of much of Europe and the northern United States, the ground is carrying you at about 1,180 kilometers an hour, still faster than most airliners fly. And if you could stand exactly on the North Pole, you would simply turn in place once per day, going nowhere at all. Same planet, same rotation, and your speed depends entirely on where you happen to be standing on its surface. So already we have to be careful with the word speed. Your rotational speed is a real number, but it is a number relative to the axis of the Earth, and it changes depending on your latitude. That should make you a little suspicious, in a useful way. Speed, it turns out, is always speed relative to something. Hold that thought. It is going to come back and matter enormously. But let me stay with the strangeness of the spin for a moment longer, because there is something worth feeling here. Everything you have ever done, you did while turning. Every conversation, every meal, every night of sleep, all of it happened on a surface sweeping eastward faster than sound. When you watch the stars appear to wheel slowly across the sky over a night, you're not watching the stars move. You're watching your own rotation, From the inside, the whole sky turning because you're turning under it. The ancients built entire cosmologies around the idea that the heavens revolved around a still earth, and it was one of the hardest ideas in the history of science to overturn, precisely because the stillness feels so total. You cannot feel the spin. You can only see its shadow, in the slow march of the sun and the stars. There is a way to actually see the spin, if you know how to look, and it is one of the quietest and most dramatic demonstrations in all of science. In 1851, a French physicist named Léon Foucault hung a heavy weight on a very long wire from a high ceiling in Paris and set it gently swinging. A pendulum, left alone, wants to keep swinging in the same flat plane. But over the hours, Foucault's pendulum appeared to slowly turn, its plane of swing rotating around the room. The pendulum was not turning. The floor was. The whole building, the whole city, the whole country was rotating underneath the swinging weight, and the pendulum, faithful to its own straight line, revealed it. People came and stood and watched the earth turn beneath a swinging weight with their own eyes. You can still find Foucault pendulums in science museums around the world today, slowly knocking over little pegs set in a circle, each peg falling not because the pendulum moved to it, but because the earth carried the peg into the pendulum's path. The spin leaves other fingerprints too, ones large enough to shape the weather over whole continents. Because the earth turns, anything moving across its surface over long distances gets subtly deflected, nudged sideways by the simple fact that the ground is rotating beneath the motion. This is called the Coriolis effect, and it is why large storm systems spin, why hurricanes and cyclones curl into their long spirals, turning one way in the northern hemisphere and the opposite way in the southern. The great rotating storms you see on weather maps are, in a real sense, portraits of the planet's spin, drawn at a scale large enough for the turning to matter. The coffee in your cup is far too small for the effect to touch. A hurricane 1,000 kilometers wide is not. The spin is not even perfectly steady, which is a strange thought on its own. The moon's gravity raises tides in our oceans, and the drag of those tides acts as a gentle brake on the Earth's rotation, so the length of the day is very slowly increasing, by something like 1 or 2/1000ths of a second per century, over a human life that is nothing. But stretch it across hundreds of millions of years and it adds up. In the age of the earliest corals, a day was only about 22 hours long, and a year held more of those shorter days. The spin that feels so fixed and eternal is, in fact, gradually winding down, and every so often we have to slip an extra leap second into our clocks to keep our timekeeping in step with the slowing turn of the world. So the spin is real, provable, visible in a swinging weight and a spinning storm, and even slowly changing over the ages. And still, standing on the ground, you feel none of it. You have to build a pendulum, or map a hurricane, or compare atomic clocks across decades to catch the planet in the act of turning. Your body, left to itself, insists you're perfectly still while it swings you eastward faster than sound. That is the strange signature of the second rung, a motion you can prove a dozen different ways and feel in none of them. And here is where it starts to compound. The spin is real, but it is only the smallest motion you're making. It is the gentle one, the one closest to home. Because while the ground turns you around once a day, the entire planet, the whole spinning ball of it, is doing something far faster. It is falling. Not down, not toward anything you would call below, but sideways and forever, around a star. And the speed of that fall makes the spin look like standing still. Go outside in your mind and look at the sun again, but this time do not think about the day. Think about the year. Over 12 months, the sun appears to drift slowly against the background of the distant stars, moving through the constellations, the ones the old astrologers named. Again, it looks like the sun is doing the moving, and again, it is not. That slow annual drift is you, and the whole earth with you, travelling all the way around the sun and looking out at it from a slightly different angle each night. The earth is not sitting beside the sun. It is orbiting it, held on a curved path by gravity, and the speed of that orbit is the third rung of our ladder. The Earth orbits the Sun at an average speed of about 30 kilometers every second. Let that unit land properly. Not 30 kilometers an hour, not 30 kilometers a minute, 30 kilometers in a single second. In the time it takes you to say the words "the Earth is moving," the Earth has moved something like 60 or 90 kilometers along its orbit. Converted into the units of a car speedometer, this is roughly 107,000 kilometers an hour, or about 67,000 miles an hour. The planet you're lying on, the one that feels so motionless that you would swear an oath on it, is hurtling around the sun at 67,000 miles an hour. Compare that to the rung below it and feel the jump. The spin at the equator carried you at a little over 1,000 miles an hour. The orbit is carrying you at 67,000. That is more than 60 times faster. And yet, of the two, the orbit is even more completely undetectable. You can at least point to the spin and watch the sun cross the sky in a day. The orbit hides itself almost perfectly, and the reason it hides is the single most important idea for understanding everything that comes next. The Earth is not being pushed around the sun. It is falling around it. Falling is the right word, and it is not a metaphor. Isaac Newton worked this out with a thought experiment about a cannon on an impossibly tall mountain. Fire a cannonball weakly and it arcs down and hits the ground a short distance away. Fire it harder and it goes farther before it falls. Now imagine firing it so hard that as it falls toward the Earth curves away beneath it at exactly the same rate. The cannonball keeps falling, but it never gets any closer to the ground. It falls forever all the way around the planet and comes back to hit you in the back of the head. That is an orbit. An orbit is not a state of floating above gravity. It is a state of falling so far sideways that you continually miss what you are falling toward. This is why you cannot feel the orbital motion at all, not even the faint whisper you get from the spin. When you are in free fall, everything around you falls together, and there is no force pressing you against anything. It is the same reason astronauts float inside the space station. They are not beyond gravity up there. Gravity at the height of the station is nearly as strong as it is on the ground. They float because they and their station are falling around the Earth together, continuously, and falling together feels exactly like weightlessness. The whole Earth, and you on it, are doing the same thing around the sun. We are all in free fall around a star, every one of us, all the time, and free fall is the most perfectly unfeelable motion there is. So picture the size of what is happening. Over the course of a year, this 67,000 mile an hour motion carries the Earth around a loop nearly 1 billion kilometers in circumference. The ground you call still completes a circuit of that size every 12 months without so much as a shudder. You have personally travelled that 1 billion kilometer loop once for every year you have been alive, and you have felt none of the trips. The water in the glass has ridden all the way around the sun with you sitting flat the entire way. And here the earlier suspicion comes back, sharper now. I told you the orbital speed is about 30 kilometers a second, but 30 kilometers a second relative to what? Relative to the sun. That is the thing we are measuring against. The Earth moves at 30 kilometers a second with respect to the sun, the way a horse on a carousel moves with respect to the center of the carousel. But the sun is not a fixed post hammered into the middle of the universe. The sun is not standing still either. So the number, 67,000 miles an hour, is true, but it is true only in relation to a sun that is itself in motion, and we have not even begun to account for that motion yet. This is the pattern that is going to repeat all the way up the ladder, so let me name it plainly now. Every speed we have found is a speed relative to something, and each of those somethings turns out to be moving too. The ground turns relative to the axis of the Earth. The Earth falls relative to the sun, and the sun, as we are about to see, is racing relative to the center of the galaxy. Each rung is measured against a platform that is itself sliding. It is speeds all the way down, each one riding on top of a larger one, none of them anchored to anything you could honestly call still. You might already feel where this is heading, and it is a genuinely uncomfortable thought. In the quiet way this channel likes discomfort. If every speed is relative to something that is also moving, then is there any such thing as your real speed? Is there a true motion underneath all these relative ones, or is it relative motions all the way to the bottom, with no floor? Hold that question. We are going to run straight into it, hard, in a few rungs, and it is going to look for a moment like the whole question of how fast are we going has no answer at all. There is a direct proof that the Earth orbits the Sun, and it was found by watching the stars tilt. In 1725, an English astronomer named James Bradley was trying to measure the tiny shifts in a star's position that should come from the Earth moving to opposite sides of its orbit. He found a shift, but not the one he was looking for, and it pointed in the wrong direction to be what he expected. What he had actually discovered was something subtler and, for our purposes, more beautiful. As the Earth moves along its orbit, the light coming down from a star appears to tilt slightly. The way rain falling straight down seems to slant toward you when you run through it, and to slant the other way when you turn and run back. Bradley was watching starlight slant because the Earth beneath his telescope was rushing sideways through space at tens of thousands of miles an hour. It was the first direct physical proof that the Earth truly moves around the Sun, and it came from noticing that the whole sky leans, ever so slightly, in the direction we're travelling. The orbital speed is not even perfectly constant, which is worth a moment because it corrects a stubborn misunderstanding. The Earth's orbit is not a perfect circle, but a gentle ellipse, so we are slightly closer to the Sun at some times of year and slightly farther at others, and by a law worked out by Johannes Kepler 4 centuries ago, we move a little faster when we are closer, and a little slower when we are farther. We are actually at our closest to the Sun, and moving fastest in early January, and at our most distant moving slowest in early July. If that surprises you, it is because the seasons have nothing to do with our distance from the Sun. They come entirely from the tilt of the Earth's axis, which leans one hemisphere toward the Sun and then the other as we go around. The northern winter happens to fall when we're nearest the Sun and moving quickest. Distance is not what makes it cold. The angle of the light is. Try to feel the distance this fall covers in an ordinary day. Moving at 67,000 miles an hour, the Earth travels something like 2.5 million kilometers along its orbit every single day. While you sleep tonight, one full night's rest, you and the entire planet will move nearly 1 million kilometers along the great curve around the Sun. You will wake in a place hundreds of thousands of kilometers from where you closed your eyes, and it will feel exactly like the same bed in the same room, because the bed and the room and the whole planet made the journey with you, together, without a tremor. The distance is real, and the stillness is real, and this is now the third time we have had to hold both of those at once. And once again, quietly, the number rests on a hidden foundation. 67,000 miles an hour relative to the Sun, always relative to something. The Earth moves that fast with respect to the Sun, exactly as a horse on a carousel moves with respect to the centre of the ride, and the whole meaning of the speed depends on treating the Sun as a fixed post to measure against. But the Sun is not a fixed post, but we are not there yet. There is a much bigger motion to account for first, and it dwarfs everything we have said so far. The spin gave us 1,000 miles an hour. The orbit gave us 67,000. The next rung is going to give us 500,000, and it is not the Earth doing the moving this time. It is the Sun carrying the Earth and every other planet with it, plunging through the galaxy at a speed that makes our fall around the Sun look like a slow drift. Look up at the pale band of the Milky Way, if you have ever been lucky enough to be somewhere dark enough to see it. That soft river of light is the disk of our galaxy seen edge on. From the inside, hundreds of billions of stars smeared into a glowing haze by sheer distance. We live inside that disk, about halfway out from the centre, in one of the spiral arms, and the whole thing is turning, slowly and enormously, like a wheel that takes 250 million years to complete a single turn. We are on that wheel, and we are riding it fast. The Sun, carrying the Earth and every other planet with it, orbits the centre of the galaxy at a speed of about 230 kilometers every second. Take a moment with that unit again, because it is easy to let it slide past. 230 kilometers in 1 second. That is roughly 828,000 kilometers an hour, or about 514,000 miles an hour. The most recent measurements, from a European spacecraft called Gaia, that has been carefully mapping the positions and motions of over 1 billion stars, actually nudge that figure a little higher, closer to 240 kilometers a second. Either way, this is the 4th rung of our ladder, and look how the ladder has grown. 1,000 miles an hour for the spin, 67,000 for the orbit around the Sun, and now 500,000 miles an hour for the plunge around the galaxy. You are, at this moment, being carried around the centre of the Milky Way at 500,000 miles an hour, and the water in the glass is still flat. Say that to yourself once, slowly. Every rung we climb, the speed multiplies, and the stillness stays perfect. The gap between what you feel and what is true is no longer a crack. It is a canyon. Let me set the size of the thing we are circling, because the speed only means something against the scale. The Milky Way is a flattened disk of stars something like 100,000 light-years across, holding somewhere between 1 and 400 billion stars wound into great spiral arms. We live partway out, in a minor arm sometimes called the Orion Arm, about 26,000 light-years from the centre, far enough out that the crowded, brilliant core is hidden from us behind intervening clouds. That pale band of light across a dark night sky is this same disk, seen edge on from our place inside it. the combined glow of hundreds of billions of stars too far away to separate. We are not looking at the galaxy from outside, we are looking at it from within, along the plane of the plate, which is why it appears as a band rather than a spiral. So when I say the sun carries us around this structure at 500,000 miles an hour, hold the size beside the speed. We are moving fast enough to cross the distance from the Earth to the Moon in under a minute, and yet set against the width of the galaxy, that blistering pace barely registers. It takes 250 million years just to go around once. The galaxy is so large that even 500,000 miles an hour is, in its terms, a slow and patient drift, a single grain of sand's worth of progress along a shore that runs on beyond sight. Speed is always a comparison, and against the galaxy, our enormous speed becomes almost gentle. And still, and this is the refrain that will not stop being true, you feel none of it. 500,000 miles an hour around the centre of a 100,000 light-year disk, and the water on your nightstand is flat, the blanket is warm, the room is quiet. The scale has grown past anything the human mind can properly hold, and your body's report has not changed by a hair. Not moving, it says. Not moving at all. Where is the centre you're orbiting? It sits about 26,000 light-years away from us, off in the direction of the constellation Sagittarius, hidden behind thick clouds of stars and dust. At the very heart of it is a supermassive black hole, and around that heart the entire disk of the galaxy wheels. We are not near the middle. We are out in the suburbs, on a quiet arm going around and around, and one full trip around, one complete orbit of the galaxy, takes an amount of time that is genuinely hard to hold in the mind. It takes somewhere between 225 and 250 million years. Astronomers sometimes call this length of time a galactic year. Let me make that number mean something, because on its own it is just a large figure. The last time the Sun was in the position it occupies right now, on this particular lap around the galaxy, the very first dinosaurs were beginning to appear on Earth. The continents were fused into a single mass. There were no flowers yet, no grass, no birds. An entire epoch of life, the whole rise and reign and extinction of the dinosaurs, the emergence of mammals, the arrival of primates, the invention of everything human beings have ever invented, has happened in the time it has taken us to travel roughly once around the galaxy. And the solar system, in its entire 4.5 billion year existence, has only completed about 20 of these laps. We are, as a planet, about 20 galactic years old. Now I want to slow down and show you what this actually looks like, because the picture is stranger than a simple circle. Imagine you could rise up out of the galaxy entirely, far enough that you could see the Sun as a single moving point of light, sliding forward through the disk at 500,000 miles an hour. Watch it move. Now look closer at the planets, because the Sun is not sitting still with the planets going around it in neat flat rings. The Sun is racing forward, and the planets are trying to orbit it at the same time. So each planet does not trace a circle, it traces a stretched-out spiral, winding around the path of the moving Sun like the thread of a screw, like a great slow hand drill boring forward through the dark. The Earth loops around, but by the time it comes back to where it started its loop, the Sun has already carried the whole system far ahead, so the loop never closes. It smears forward into a helix. You have been spiraling through the galaxy your entire life, drilling forward through space along a corkscrew millions of kilometers wide, and you have felt the entire time as though you were lying perfectly still. Hold that image, the screw turning through the dark. It is the truest picture yet of what your body has been doing while it told you that you were at rest. I should add one honest caution here, because a version of this picture went around the internet some years ago that got it wrong. There was a much shared animation showing the planets trailing far behind the Sun in a dramatic corkscrew, tilted at a sharp angle, wrapped in language about a hidden truth that scientists supposedly suppress. The helix is real, exactly as I have described it, because the Sun genuinely does move forward while the planets orbit. But that animation exaggerated the geometry, tilting everything to a right angle and adding a mystical spin that the physics does not support. I mention it because it is a good example of a thing that happens often with this kind of material. The real picture is already strange enough. It does not need to be dressed up. The plain truth that we spiral through the galaxy at 500,000 miles an hour is enough to sit with. And now let us tally the ladder so far because the numbers are stacking on top of each other. You're spinning with the Earth at over 1,000 miles an hour. You're falling around the Sun at 67,000. and you are riding the sun around the galaxy at 500,000. These motions are layered, each riding on the last, so that your true path through space is a spin, riding on a fall, riding on a plunge, a curve wrapped around a curve wrapped around a curve, and every single layer is invisible to you. You might wonder how we even know the sun is moving this fast, when we cannot feel it and cannot step outside the galaxy to watch. We measure it the way you would gauge your own speed in a car with the windows blacked out except for one small gap. You watch things go by. Astronomers track the positions and motions of distant markers, the ancient globular clusters that hang in a great halo around the galaxy, and the far-off galaxies beyond our own, objects that are not caught up in the sun's particular orbit. Against those distant reference points, a whole neighbourhood of stars can be seen to stream in one direction, and the speed of that streaming is the sun's motion around the galactic centre. The spacecraft called Gaia has refined this to remarkable precision, measuring the tiny shifts in position of more than 1 billion stars, building the most detailed map of our galaxy's motion ever made. The 500,000 mile-an-hour figure is not a guess. It is a measurement, checked against the most distant, most stationary things we can find. Our path around the galaxy is not a simple flat circle either. As the sun sweeps around the galactic centre, it also bobs gently up and down through the plane of the galactic disk, like a horse on a carousel that also rises and falls, crossing the crowded midplane of the galaxy and lifting above it and sinking back over and over every few tens of millions of years. Each time we pass through that dense midplane, we move through thicker clouds of gas and dust and a higher concentration of stars. Some scientists have wondered, cautiously and speculatively, whether these regular passages through the crowded plane might stir distant comets or line up with events in Earth's long history, though that remains an open and much debated idea rather than an established fact. What is certain is that our motion through the galaxy is richer than a circle. It is a rise and fall wound into a forward sweep wound into a spiral, layered motion within layered motion. Try to feel the sheer traffic of it. As the sun carries us around the galaxy at 500,000 miles an hour, we are moving through a region scattered with other stars, each of them on its own orbit, at its own speed and angle. We do not notice them streaming past because the distances between stars are so enormous that even at 500,000 miles an hour the scene changes with the slowness of geology. The nearest star to the Sun is more than 4 light-years away, so far that our blistering galactic speed barely closes the gap on the timescale of a human civilization. We are moving through a crowd so spread out that it looks, from the inside, like stillness. There is that word again, stillness, standing in for a motion too large and too smooth to feel, and every rung of this we ride at once. Right now you are turning with the ground, and falling around the sun, and plunging around the galaxy, and bobbing up and down through its disk, all at the same time, all layered together, and all of it hidden beneath the flat, calm surface of the water on your nightstand. The great wheel turns once every 250 million years, and you are a few decades into a single lap that the Earth itself has completed only about 20 times in its entire existence. But here is the thing that should be nagging at you by now, the thing I have deliberately let build. Every one of these speeds is measured against something, the spin against the axis, the orbit against the sun, the galactic plunge against the centre of the galaxy, and that centre is not standing still either. The whole Milky Way is moving, drifting through a crowd of other galaxies, being pulled in its own direction, so the moment we ask how fast the galaxy is moving, we lose our footing completely. Because there is nothing left to measure it against. There is no bigger platform standing still that we can use as our reference, and that is where the whole question is about to fall through the floor. Stop climbing for a moment and stand still on the ladder, if you can call any of this standing still. We have 4 speeds now, each larger than the last, and every one of them is honest. But I have been slipping a small word past you at every rung, and it is time to hold it up to the light. The word is against. The ground turns against the axis of the Earth. The Earth falls against the sun plunges against the galactic centre. Every speed we have named is a speed against something else, and that turns out to be the deepest problem in the whole subject. Here is the trap, laid out plainly. Suppose I ask you how fast you're moving, and I do not let you answer against something. No against the road, no against the sun, no against the galaxy. Just, how fast are you moving? Full stop, absolutely, in and of yourself. Can you answer? You cannot. Nobody can. And this is not because we lack a good enough instrument. It is because, as far as the laws of physics can tell, the question has no answer. There is no such thing as your absolute speed. There is only your speed relative to some other thing you have chosen. Go back to Galileo's ship, the sealed cabin gliding across smooth water. Inside, everything behaves exactly as it would on land. Now put two such ships on the sea, passing each other smoothly in the night, each sealed, each with a physicist inside dropping balls and watching them fall straight down. Ask each physicist, are you moving? Each one, running every experiment available, will find the same answer. The physics in my cabin is perfectly normal. Balls fall straight. Nothing pushes on me. By every test I can perform, I am at rest, and it is the other ship that is moving past me. And here is the unsettling part. They are both right. There is no experiment, none, that either physicist could run inside their sealed cabin to prove which of them is really moving and which is really still. The question which one is truly at rest is not a hard question. It is a meaningless one. This is what Einstein built into the bedrock of physics. There is no privileged, absolute frame of rest anywhere in the universe that experiments can detect. Motion at a steady speed is always, only, relative. If you are floating in the dark of deep space and another object drifts past you, you cannot say whether you are still and it is moving, or it is still and you are moving, or you are both moving. All three descriptions are equally, exactly true. The universe does not come with a set of fixed mile markers hammered into empty space. There is no wall to measure against. There is no cosmic post that says you are here, at rest, and everything else moves relative to you. Feel what this does to our whole project. We set out tonight to answer a simple question. How fast are we really going? And we climbed a beautiful ladder of speeds, each one larger and more hidden than the last. And now, at the top of the ladder, the question itself seems to dissolve in our hands. Really going, compared to what? There is no ultimate what. Every speed is relative to some other moving thing, and there is no thing at the bottom holding still to anchor the whole stack. It is relative motion all the way down, with no floor. I want to sit in this for a moment, because there is something here that is worth feeling and not just understanding. We use the word still constantly. Sit still. Stand still. The still of the night. And we imagine that still names a real state, a thing an object can be, a kind of rest that is definite and absolute. But it does not. Nothing in the universe is still in that absolute sense, and more than that, nothing can be. Because absolute stillness is not a physical condition at all. It is not that everything happens to be moving and we just cannot find the one still thing. It is that still, the absolute kind, is not a property the universe recognizes. When you say you are sitting still, you always, secretly, mean still relative to the room, and the room is turning and falling and plunging and drifting. The stillness you have trusted your entire life was never a fact about you. It was only ever a comparison, and a local one. That is a strange thing to absorb lying in a bed that feels so solid. The floor beneath you was never still. Not because it is vibrating, not because of some flaw, but because there is no such thing as the still it seemed to have. It never could have had it. Still was always a story you told about the relationship between you and the nearest large objects, and it was a true story about that relationship, and it was never anything more. Take away the room, take away the earth, take away the sun, and ask for your stillness on its own, and there is simply nothing there to point to. The word runs out of world to describe. There is a common way people try to escape this conclusion, and it is worth heading off because it feels so reasonable. Surely you might think, even if I cannot feel my motion, there must still be some real fact about who is truly moving and who is truly still. Surely the universe knows, even if I do not. But that is exactly the intuition the physics dismantles. It is not that the information is hidden from us. It is that there is no such fact to hide. Two observers gliding past each other, each perfectly entitled to call themselves at rest, are not one right and one wrong with the truth concealed. They are both right, fully, and the question of which is really moving has no more content than asking which end of a stick is the true top. Top is relative to how you hold it. Rest is relative to what you compare it to. This has a strange and freeing consequence for the whole universe. There is no centre of the cosmos, no special still point around which everything else turns, no throne of absolute rest. Every galaxy, everywhere, can regard itself as the still one with the rest of the universe moving around it, and the laws of physics will play out identically for all of them. When you lie in your bed tonight and feel like the fixed point at the middle of a quiet world, you're not deluded. You're as entitled to that view as any being anywhere. It is only that every other creature on every other world is equally entitled to the very same view, and none of you is wrong, because there is no privileged stillness for any of you to be right about. So the question, how fast am I really going, asked in the absolute, against nothing in particular, is not a hard question with a hidden answer. It is a question with no answer at all, because the thing it asks for does not exist. And that, strangely, is progress, because it tells us exactly what we would need to make the question meaningful again. We would need something to measure against, something real, something spread through all of space that we could all agree to treat as the reference. We have no right to expect such a thing to exist, and yet. So where does that leave us? It would seem to leave us stuck. If absolute motion is meaningless, then the honest answer to how fast are we really going is that there is no such thing as really, and the question is malformed, and we should pack up and go to sleep. For most of the history of physics, that is more or less where the matter rested. There is no absolute speed. There is no cosmic reference frame. The question has no answer. It is worth feeling how strange and how settled this idea really is, because it took some of the greatest minds in history to accept it. Isaac Newton, who built the whole framework of motion and gravity, believed there was such a thing as absolute space, a fixed, invisible stage on which everything moved, a true rest against which all motion could in principle be measured. It was a natural thing to believe. It matches our intuition perfectly. But Newton could never point to it, never find a way to detect it, and later thinkers grew suspicious of a stage that could never, even in principle, be seen. A physicist named Ernst Mach argued that motion only ever means motion relative to other matter, that absolute space was a ghost. And then Einstein made the ghost unnecessary. In his physics, there simply is no absolute stage, no fixed rest, and the laws of nature come out identical for everyone moving smoothly, whatever their speed. The stage was quietly removed, and physics worked better without it. There was even an experiment that went looking for our absolute motion and came back empty-handed, and its failure changed everything. In the late 1800s, physicists believed light must travel through some invisible medium filling all of space, which they called the ether, and they reasoned that as the Earth moved through this ether, we ought to be able to detect our motion against it, a kind of ether wind blowing past us. In 1887, two scientists named Michelson and Morley built an instrument of exquisite sensitivity to catch that wind, to measure the Earth's absolute motion through the medium of space. They found nothing. No wind, no absolute motion, no fixed frame. It was one of the most famous empty results in the history of science, and it helped clear the ground for Einstein's insight that there is no absolute rest to measure against at all. The universe was tested directly for a fixed stage, and it declined to have one. So sit for a moment in what this really means for you, lying there. When you say you are still, you have always, secretly, meant still relative to the room, and the room is turning, and falling, and plunging, and drifting. There is no deeper stillness underneath that comparison, no true rest you are secretly enjoying. Absolute stillness is not a state you have failed to reach. It is not a state at all. It is a word that describes a relationship, the relationship between you and the nearest large things, and outside that relationship it simply has nothing left to point to. The floor beneath you was never still, not because it trembles, but because the stillness it seemed to have was never a real property of anything. It was always a story about you and the floor together, and it was true as that story, and it was never anything more. That is a genuinely disorienting thing to absorb, and I do not want to rush past it, because it is the quiet heart of tonight. You have spent your whole life inside the word still, trusting it, resting in it, and it turns out to be a borrowed word on loan from whatever you happen to be measuring against. Take away the room, take away the earth, take away the sun and the galaxy, and ask for your stillness on its own, all by itself, and there is nothing there. The question runs out of world to answer it. You are never standing still. You could never have been standing still, and somehow, at the very same time, the water in the glass is flat, and the night is quiet, and you are resting. Both of those things are true, and holding them together is the strange and gentle work we're here to do. Except that it does have an answer. or very nearly one. Because there is, it turns out, one thing that fills the entire universe, that is spread through all of space, and that sits, on average, at rest with respect to the cosmos as a whole. We did not invent it, and we cannot move it. It was left behind by the birth of the universe itself, and it has been washing silently through you this entire video. If you can measure your motion against that, you get something as close to a true speed as the universe will ever give you, and we can measure our motion against it. That is the door in the wall. Let me show you what is on the other side. In 1965 in New Jersey, two radio engineers named Arno Penzias and Robert Wilson were trying to get rid of a noise. They had a large, sensitive, horn-shaped antenna, and no matter where they pointed it in the sky, they picked up a faint, steady hiss. It did not come from a city, or from the sun, or from any single point in the sky. It came from everywhere, evenly, day and night, all year. They checked everything. They famously even scrubbed out the droppings of pigeons that had nested in the antenna, thinking the mess might be the source. The hiss remained. What they were hearing, it turned out, was not a problem with their equipment. It was the oldest light in the universe, and they had stumbled onto one of the most important discoveries in the history of science. That hiss is called the cosmic microwave background, and to understand what it is, you have to go back to the beginning. When the universe was very young, it was unimaginably hot and dense, a fog of particles too energetic for light to travel freely. Then, about 380,000 years after the beginning, the universe cooled just enough for that fog to clear, and light was suddenly free to stream across space. That light has been travelling ever since, for nearly 14 billion years, stretching and cooling as the universe expanded around it. Today, it is no longer a blazing glow, but a whisper of microwaves, cooled all the way down to just 2.725 degrees above absolute zero, the coldest temperature there is. And it fills all of space, in every direction, the faint leftover warmth of creation itself. Here is the first thing that matters for us. This ancient light is almost perfectly smooth. If you measure its temperature in one direction, and then in the opposite direction, you find it is the same to an astonishing degree, matching to within tiny fractions of a degree across the entire sky. It is the most uniform thing we have ever measured. It is the same, everywhere you look, a steady 2.725 degrees. Almost. And the almost is the whole point. When we measure the cosmic microwave background very carefully, we find that it is not quite perfectly even. There is a pattern, the largest and simplest pattern in the sky, and it looks like this. In one particular direction, the background is very slightly warmer than average. In exactly the opposite direction, it is very slightly cooler. Warmer on one side of the sky, cooler on the other, a smooth gradient between them. This lopsidedness is called the dipole, and the difference is tiny, only about 0.003 of a degree, roughly 1 part in 1,000. But it is real. It is measured to great precision, and its cause is beautiful in its simplicity. The reason one side of the sky is warmer is that we are moving toward it. This is the same effect you have heard 1,000 times without thinking about it. When an ambulance races toward you, its siren sounds higher, the sound waves bunched up by its approach. As it passes and speeds away, the siren drops lower, the waves stretched out behind it. Light does the same thing. Move toward a source of light and it shifts slightly bluer and looks slightly warmer. Move away from it and it shifts slightly redder and cooler. So as we move through the universe, we are moving toward the cosmic microwave background on one side and away from it on the other. The side we are heading toward looks warmer, the side we are leaving looks cooler. That faint warm spot in the sky is not a place. It is a direction. It is the direction we're going. Let me put the smallness of this dipole in perspective, because its subtlety is part of its beauty. The difference between the warm side of the sky and the cool side is only about 0.003 of a single degree. If the whole background glow were a still pond at one even temperature, our motion tips it so gently that one shore comes out a few thousandths of a degree warmer than the other. It is a whisper of a signal, far too faint for any human sense, catchable only by instruments cooled and shielded and flown above the atmosphere. And yet that whisper is one of the most information-rich features in the sky, because it is not noise and it is not structure in the early universe. It is us. It is our own velocity, printed faintly across the entire heavens by nothing more than the fact that we are moving through the light. The warm side points toward the constellation Leo, and the cool side toward the opposite patch of sky, and that line from cool to warm is the direction the sun is travelling against the background of the whole universe. You cannot see it with your eyes, of course. To your eyes, the night sky is the same darkness everywhere. But to a sensitive enough microwave detector, the sky carries a faint warm glow on one side, like the barely perceptible heat you feel on one cheek from a fire across a large dark room, and that warmth is the direction of our motion, marked out by the oldest light there is. Now think about what this gives us, because it is exactly the thing we thought we had lost. The cosmic microwave background fills all of space, and it sits, on average, at rest with respect to the universe as a whole, because it was born from the whole universe at once. It is not tied to the Earth, or the Sun, or the galaxy. It is the closest thing there is to a fixed backdrop against which motion can be measured, not because it is a wall hammered into space, but because it is the average rest of all the matter and light in the cosmos, and we can measure our motion against it precisely, just by reading how warm the sky is on one side compared to the other. The leftover glow of the Big Bang is, quite literally, a speedometer, and it has been shining through you, through the room, through the flat surface of the water in the glass the entire time we have been talking. Let me be careful and honest about what this is, because it matters. This does not bring back an absolute privileged frame of rest of the kind Einstein ruled out. The laws of physics still work exactly the same whether you move relative to the background or not. There is no experiment in your sealed cabin that the background lets you cheat. What the cosmic microwave background gives us is not a law-breaking absolute rest, but something more modest and, for our purposes tonight, more useful. It gives us a natural, universe-wide reference, the one frame in which the oldest light looks the same in all directions. It is the rest frame of the cosmos itself, the frame in which, on the larger scale, everything averages out to stillness. And measuring our speed against that is the nearest thing to a true speed the universe will ever hand us. The story of how that hiss was recognized is one of the great near misses in science, and it is worth telling. While Penzias and Wilson were puzzling over their stubborn noise, a team of physicists at Princeton, led by Robert Dicker, had worked out that if the universe began in a hot dense state, there ought to be a faint afterglow left over, cooled by the ages to just a few degrees above absolute zero, and they were actually building an antenna to look for it. They were about to go hunting for exactly the thing that Penzias and Wilson had already found by accident and could not explain. When the two groups were put in touch, the meaning of the hiss became clear at once. The noise the engineers had been trying to scrub away was the afterglow the theorists had been preparing to seek. Penzias and Wilson later received the Nobel Prize for stumbling onto the oldest light there is while trying to get rid of it. Over the decades since, we have mapped that ancient light with great care, using a series of dedicated spacecraft. In 1992, a satellite called COBE measured the background across the whole sky and confirmed both its temperature and the faint dipole, the warm side and the cool side, our motion written into the heavens. Later missions with names like WMAP and Planck sharpened the picture until we held the most detailed map of the infant universe ever made. And in all of that mapping, the dipole, our own motion, is by far the largest feature in the sky, far larger than the minute ripples that trace the seeds of galaxies. Before astronomers can even study those seeds, they have to carefully subtract out the dipole, our own speed, because our motion shouts so much louder than the ancient structure they are trying to hear. Our velocity is not a subtle footnote in the data. It is the single loudest thing written across the oldest light in existence. There is a homely way to meet this light too, one you may have brushed against without knowing. In the days of old analog televisions, when a set was tuned between stations, a small fraction of the snow and static that danced on the screen was caused by this very background, the faint microwave glow of the early universe reaching your living room. A little of that random hiss was light that had travelled for nearly 14 billion years, since before there were stars or planets, only to end its long journey as a speck of static on a television set. The beginning of the universe has been quietly touching us the whole time, in the noise between channels, in the warmth on one side of the sky, in the hiss a careful antenna can never quite escape. And feel, for a moment, how cold 2.725 degrees above absolute zero really is. Absolute zero is the coldest temperature that can exist, the point where all heat has drained away, and the background sits just barely above it, colder than anything that occurs naturally anywhere on Earth. colder than the deepest shadowed craters of the moon. That is what fills all of space, in every direction, the thin, frigid remnant of a fire that once filled the whole universe. It is the cooled ember of creation, spread so thin and chilled so far that it is now the quietest, coldest, most even thing there is. And it is precisely because it is so even, so nearly the same in all directions, that the one small unevenness, the warm smudge on one side, stands out clearly enough to become our speedometer. So we are finally ready to ask the question again, the one that seemed to have no answer, and this time to get a real number back. How fast are we going, measured against the background glow of the entire universe? Not against the sun, not against the galaxy, but against the cosmos as a whole. The answer is waiting in that faint warm smudge on one side of the sky. And when you work it out, it is larger than every rung of the ladder we have climbed so far combined. It is the true speed the whole night has been building toward, and once you have it, it immediately forces a second question that is even harder to shake. Not just how fast, but toward what? Picture the faint warm smudge on one side of the sky, the warm side of the cosmic background, the direction we are heading. We are finally going to read the speedometer and say the number out loud, and I want you to keep the glass of water in the corner of your mind while I do it. That flat, calm surface on the nightstand, because the number and the calm are about to sit side by side in a way that should feel almost impossible. Measured against the cosmic microwave background, against the leftover glow of the entire universe, the sun is moving at about 370 kilometers every second. Let that settle for a moment against the rungs we have already climbed. The spin was 1,000 miles an hour, the orbit around the sun was 67,000, the plunge around the galaxy was 500,000, and now the sun itself, measured against the universe as a whole, is moving at 370 kilometers a second, which comes out to roughly 826,000 miles an hour. In a single second, you and the sun and everything with you move 370 kilometers against the background of the cosmos. That is farther than the length of many entire countries, crossed in the time it takes to say the word second. And we are not done, because the sun is only one star in a galaxy, and the galaxy itself is moving, and even our galaxy is only one member of a small crowd of galaxies called the local group, bound together by gravity, drifting through space as a unit. When astronomers correct for the sun's motion around the galaxy, and the galaxy's own motion, and add it all up to ask how fast our entire local group of galaxies is moving against the cosmic background, they get an even larger number. The whole local group is moving at roughly 620 kilometers every second relative to that background glow. Converted into the units we started with, that is about 1.3 million miles an hour. There it is. That is the answer to the question the whole night has been circling. How fast are we really going, measured against the most honest reference the universe can offer? About 1.3 million miles an hour. You, lying in your bed, on this calm and ordinary night, are being carried through the universe at 1.3 million miles an hour, and the surface of the water in the glass is not moved by the width of a hair. Let me try to make that speed real, because 1 million miles an hour is so far outside human experience that it risks becoming just a shape of words. At 1.3 million miles an hour, you could cross the entire United States coast to coast in about 7 seconds. You could travel from the Earth to the Moon, the 3-day journey that the Apollo astronauts made, in roughly 11 minutes, the fastest spacecraft humans have ever built. The probes we have flung toward the sun with every trick of engineering we possess do not come close to this speed. And you are doing it right now, without engines, without motion sickness, without the faintest sensation, simply by lying still on the surface of a planet. I have to pause and correct something here, because you may run into it, and it is wrong. You will sometimes see this motion quoted as 14 million miles an hour. That figure gets repeated in articles and videos, and it is a straightforward mistake, off by a factor of 10. 600 kilometers a second works out to about 1.3 million miles an hour, not 14 million. It is worth getting right, not to be pedantic, but because the real number does not need any inflation. 1.3 million miles an hour is already faster than anything you will ever build or ride. The truth is dramatic enough on its own. It almost always is. Now let me gather the whole ladder together in one place, because we have climbed a long way, and it is worth standing at the top and looking down at every rung at once. You're spinning with the Earth at over 1,000 miles an hour. You're falling around the sun at 67,000. You're riding the sun around the galaxy at 500,000, and the entire local family of galaxies you belong to is sweeping through the universe at 1.3 million miles an hour. These are not alternatives. They are all true at the same time, stacked on top of one another, a spin riding on a fall, riding on a plunge, riding on a great cosmic drift. Your true path through space, if you could draw it, is a curve wound around a curve wound around a curve wound around a nearly straight line, 1.3 million miles an hour long, and you feel, in your body, absolutely none of it. This is the moment the title of tonight points at. Your true speed through space really is scarier than you think, and notice what the fear is actually made of. It is not the fear of crashing. Nothing is going to crash. The speed is smooth and shared and will never once touch you. The unsettling part is subtler and harder to shake. It is that a word you have leaned on your entire life, the word still, has quietly turned to smoke in your hands. You are not still. You have never been still. You cannot be still. And the calm you feel, the flat water, the steady weight of the blanket, all of it is real, and all of it is happening at 1.3 million miles an hour. Both of those things are true, and holding them together is the strange work of tonight. Let me hold this number up against the machines we are proudest of, because that is where it really bites. The fastest object human beings have ever built is a space probe we sent to graze the outer atmosphere of the Sun, and at its fastest it reached a little over 400,000 miles an hour, and we rightly called that an astonishing feat of engineering, the fastest anything human has ever moved. Your local group of galaxies is carrying you at more than 3 times that speed, 1.3 million miles an hour, and it required no engine, no fuel, no heat shield, and it produces no sensation at all. The pinnacle of human speed is a small fraction of the speed you're already travelling, for free, lying still, doing nothing, tonight. It is worth being clear about how astronomers pull this number apart, because it shows how careful the reasoning is. The raw measurement, that warm smudge on the cosmic background, gives the motion of the Sun about 370 kilometers a second toward the constellation Leo. But the Sun is not a free agent. It is swinging around the galaxy, and the galaxy is drifting within the local group. So to find the motion of the local group as a whole, the true underlying drift, astronomers carefully subtract out the Sun's known orbit around the galactic center and the galaxy's motion within our small cluster. What is left, once those local swirls are removed, is the deep motion of the entire local group through the universe, about 620 kilometers a second, that 1.3 million mile an hour drift. The Sun's number and the local group's number point in slightly different directions in the sky, precisely because one still carries the swirl of our galactic orbit, and the other has had it cleaned away. Stand at the top of the whole ladder one more time and look down now that you have the final rung in hand. The ground turns you at 1,000 miles an hour. That turning ground falls around the Sun at 67,000. That falling planet rides the Sun around the galaxy at 500,000. And that whole plunging galaxy drifts with its small family through the universe at 1.3 million miles an hour. Each motion is real, each one is layered on the last, and each one was completely invisible to you until someone worked out how to measure it against something larger. The spin was measured against the axis, the orbit against the Sun, the plunge against the galactic center, and this last and largest motion against the oldest light there is. 4 rungs, 4 references, 4 speeds, and one perfectly still glass of water riding through all of it. And notice what changed at the very top, because it is easy to miss in the rush of numbers. Every rung below the last was a speed relative to something local and moving, the axis, the Sun, the heart of the galaxy. But this final speed is different in kind. It is our motion measured against the universe as a whole, against the average rest of all the matter and light there is. It is the closest thing to a true speed that physics will ever grant us. And unlike all the local speeds, which point in whatever direction the local swirl happens to send them, this one points somewhere fixed and meaningful, one definite direction through the entire cosmos. But a speed is only half of a motion. A number on its own does not tell you where you're going, and this is where the question quietly changes shape and becomes, I think, much stranger. Because we do not just have a speed, we have a direction. That faint warm smudge on the sky is not scattered randomly. It points one specific way, toward one specific patch of the heavens, and therefore toward one specific place. We are not just moving fast, We are being pulled, all of us, the whole local group together, towards something. And the moment you ask what that something is, you run into one of the most quietly disturbing facts in all of astronomy. We are being pulled toward a place we cannot see. Go outside on a clear night in the southern hemisphere, or far enough south in the northern one, and look low toward the horizon, toward the constellations Hydra and Centaurus, near a small, faint constellation called Norma. That is roughly the direction. That is where we're going. Not the sun's own heading toward the constellation Leo, but the direction the entire local group is being drawn, the direction hidden inside that warm smudge on the cosmic background. Somewhere out that way, something is pulling us, and it has been pulling us for a very long time. For decades, astronomers could see the effect without seeing the cause. In the 1970s and 80s, a group of astronomers began carefully measuring the motions of galaxies across a huge patch of sky, and they found something they did not expect. Galaxies across an enormous region were all streaming in the same direction, as if the whole neighbourhood of the universe were tilted and everything was sliding down the same slope toward a common point. It was not random. It was a flow, coherent and sweeping, thousands of galaxies all drawn the same way. The team that mapped this became known, half affectionately, as the Seven Samurai, and the thing they were all sliding toward got a name that has stuck ever since. They called it the Great Attractor. The Great Attractor is a concentration of mass, an unusually dense region of the universe, whose gravity is pulling our local group and thousands of other galaxies toward it, at hundreds of kilometers a second. It sits somewhere between 150 and 250 million light-years away. Near its heart lies an immense cluster of galaxies called the Norma Cluster, a swarm of galaxies bound together, sitting about 230 million light-years from us. This is the low point of our region of the universe, the bottom of the slope, the place toward which the warm smudge on the sky has been pointing all along. This is what our 1.3 million mile-an-hour motion is aimed at. This is the answer to toward what, except you cannot look at it. And this is the detail that turns the whole story from grand to eerie. The direction of the Great Attractor, toward Norma and Hydra and Centaurus, happens to lie almost exactly along the flat plane of our own Milky Way. Remember that pale band of light across the sky, the disk of our galaxy seen edge on. It is beautiful, but it is also a wall. Along that band lies the thickest crowd of our galaxy's own stars, and worse, its thickest clouds of dust and gas, the dark lanes that blot out the light behind them, and the Great Attractor sits right behind that wall in the one direction where our own galaxy's body blocks the view. Astronomers have a name for this blinded strip of sky, and it is one of the most quietly poetic terms in science. They call it the zone of avoidance, the region of the sky that optical telescopes have always had to avoid because there is simply too much of our own galaxy in the way to see what lies beyond. Let me make sure the strangeness of this lands, because it is easy to say and hard to feel. We can measure our speed toward the Great Attractor. We can point to it on a map. We know roughly how far it is and roughly how massive it must be. And yet, when we turn an ordinary telescope toward the exact place we are falling, we see our own galaxy in the way, a curtain of near stars and dust drawn across the very spot. We are being carried at over 1,000,000 miles an hour toward a destination that is hidden behind the thing carrying us. The galaxy that gives us our night sky, our home, our whole view of the universe, is also the one object positioned to hide the place we are going. I want you to stand in that for a moment, in the second person, in the dark. Imagine you're standing outside on that dark night, and you turn to face the exact direction of our motion, low, toward the southern horizon, toward Norma. You're looking straight down the path we're travelling, straight toward the thing that is pulling more than 100,000 galaxies, including everything you have ever known, toward it. And what do you see? You see the brightest, busiest, most crowded part of the entire night sky. You see the thick band of the Milky Way, glowing with the light of nearer stars veined with black rivers of dust. You're staring directly at your destination, and your own home is standing in the doorway, filling it, so that the place you're going is nothing but a warmth you can measure and a darkness you cannot pierce. You lift the most powerful ordinary telescope ever made, point it exactly along your direction of travel, and it shows you dust. The one direction that matters most is the one direction you were built to be unable to see. That is the ache at the centre of this part, and it is a specific kind of ache. It is not the fear of something coming toward you. It is the strangeness of a destination you can name but not look at. a place you are certainly going and can never quite face. We have learned to cheat around it a little. Light that our eyes and ordinary telescopes cannot use, X-rays and infrared and radio waves, can slip through the dust where visible light cannot, and by using those, astronomers have begun to map the shapes behind the curtain, to sketch the clusters hiding in the zone of avoidance. But the plain human fact remains. In the light we were born to see, the direction of our journey is blocked by our own galaxy, and we are moving toward it anyway, at 1.3 million miles an hour in the dark. The discovery of the Great Attractor did not arrive in a single moment. It built slowly, out of a puzzle in the numbers. In the late 1970s and through the 80s, astronomers measuring the motions of galaxies kept finding the same odd thing. Galaxies were not simply drifting apart with the general expansion of the universe. On top of that expansion, across an enormous stretch of sky, they were all leaning the same way, all sliding toward one region, as though the whole neighborhood of the cosmos were gently tilted. The team of astronomers who pinned this down, remembered now as the Seven Samurai, published their findings and gave the unseen pull its name. They could not see what was doing the pulling. They could only see that everything, our own galaxy included, was being drawn the same direction, and that whatever was responsible had to be enormous. Learning to see behind the veil has taken every trick we have. Ordinary visible light cannot get through the dust of the zone of avoidance, but other kinds of light can. Infrared light, the light of heat, slips through the dust that blocks the visible, and great infrared surveys of the sky began to reveal galaxies hiding behind the galactic band that no ordinary telescope had ever caught. X-rays, given off by the hot gas that fills great clusters of galaxies, pierced the veil as well, and X-ray telescopes found the glow of massive hidden clusters lurking right in the blocked zone. Radio waves passed through untouched. Piece by piece, in the light our eyes were never built to see, astronomers have sketched the shapes behind the curtain and confirmed that there really is a great crowd of mass out there, in the exact direction of our fall, hiding behind the body of our own galaxy. Near the heart of it sits that immense swarm called the Norma Cluster, a great gathering of galaxies about 230 million light-years away, one of the most massive concentrations in our part of the universe, and one that was almost completely unknown for a long time simply because it sits squarely behind the densest part of the Milky Way. Consider that for a moment. One of the largest structures in our cosmic neighbourhood, and we very nearly missed it entirely, not because it is faint or impossibly far by the standards of these things, but because our own galaxy stands directly in front of it, in the one direction we most need to see. Stay in the strangeness of this, because it is the emotional centre of the whole journey, and it is a very particular feeling. It is not fear. Nothing out there is coming for you. It is something closer to the ache of a destination you can name but never face. Picture it once more. You are moving right now at over 1 million miles an hour in a direction as real and definite as north, toward a specific place with a specific mass and a specific distance. You can put it on a map. You can measure your speed toward it to within a few kilometers a second. And when you turn to look at it, to simply see the place you are going, your own home fills the doorway. The galaxy that gave you every star you have ever wished on, every constellation, the whole soft band of light that stirred the earliest myths, is the one object in the universe positioned exactly to hide your destination from your eyes. You are being carried somewhere you will never be allowed to look at directly, by the very thing that carries you there. And here is the thing that makes even this incomplete. The Great Attractor, for all its pull, for all the drama of a hidden destination, is not actually the whole story of where we are going. When astronomers looked closer and mapped not just the positions of galaxies, but the full three-dimensional pattern of their motion, they found that the Great Attractor is only part of a much larger structure, and only part of a much larger pull. To understand where we are truly headed, we have to zoom out one more time, far past the Great Attractor, and look at the shape of the whole current we are caught in. And when you finally see that shape, our galaxy stops looking like a traveller and starts looking like a single drop of water on an enormous silent slope. Think of a single drop of rain landing high on a mountainside. It does not choose a direction. It simply follows the slope, joining a trickle, which joins a stream, which joins a river, all of it flowing downhill toward the same distant sea, drawn by nothing more than the shape of the land. Every drop for miles around, though they never touch, are all sliding the same way, because they share the same great basin. Hold that picture, because in the year 2014, A team of astronomers used exactly this idea to redraw the map of our place in the universe, and it changed what our cosmic address even means. The team was led by an astronomer named Brent Tully, working with Hélène Courtois, Yehuda Hoffman, and Daniel Pomerade, and they did something clever. Instead of mapping galaxies by where they are, they mapped them by where they are going. They measured the motions of about 8,000 galaxies around us and asked, for each one, which way is it flowing? And then they drew the boundaries not around a clump of galaxies, but around a region of shared flow, the whole area in which every galaxy is sliding down the same great slope toward the same gravitational basin. They found that our galaxy belongs to a single connected structure of flow far larger than anything we had named before. They called it Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea is about 520 million light-years across. It contains roughly 100,000 galaxies. Its total mass is something like 100 million billion times the mass of our Sun, and it is defined, in the most beautiful way, as a watershed. Just as a mountain valley is the region where all the rain flows toward one river, Laniakea is the region of the universe where all the galaxies flow toward one gravitational low point, and that low point lies out near the Great Attractor. We do not just happen to be moving toward the Great Attractor. We live inside the enormous basin whose slope leads there. We are one drop of water in a valley 520 million light-years wide. Let me make sure the scale of that lands, because these numbers arrive so fast they can blur together. A single light-year is the distance light travels in a year, and light is the fastest thing there is, crossing the gap between the Earth and the Moon in a little over a second. In a year, light travels about 6 trillion miles. Now take that distance and multiply it by 520 million. That is the width of the basin we are sliding through. Within it, 100,000 galaxies, and remember that each single galaxy is itself 100 billion stars or more. Our entire Milky Way, all its hundreds of billions of stars, everything we discussed in the galactic plunge, is one galaxy among 100,000 in this structure, and this structure is defined by the fact that all of them are quietly, silently flowing the same way, toward the same low place, including us. And here is where our own position gets humbling in a very specific way. You might assume that if we live inside Laniakea, we must be somewhere near the middle of it, near the great basin everything flows toward. We are not. We are out near the edge, on the far rim of the watershed, sliding inward with everything around us. Our galaxy is not at the center of anything. It is a drop of water high on the slope, a long way from the bottom, moving with the whole immense sheet of the flow toward a low point hundreds of millions of light-years away. When Tully's team released their map of Laniakea, with its streams of flow all converging like the veins of a leaf toward a single point, you could find our galaxy on it only as a tiny dot, marked with a small label, far out on one of the outer filaments. You are here, the label says, on the edge of immeasurable heaven sliding in. This reframes the whole idea of where we are, and I want to dwell on that, because it is the payoff of thinking about motion instead of position. For most of history, your cosmic address was a list of places. You're on Earth, which orbits the Sun, which sits in the Milky Way, which floats in a cluster of galaxies, a stack of nested locations, each one a thing you could point to. But Laniakea says your truest address is not a place at all. It is a direction of flow. You do not simply sit in the universe, you slide through it, along with everything you can see, down a slope so gentle and so enormous that it took the careful measurement of 8,000 galaxies' motions even to notice it was there. Home is not a spot. Home is a current, and you are being carried along it. It helps to be clear about what kind of boundary Laniakea has, because it is not a wall. Laniakea is defined by flow, by which way the galaxies are sliding, and its edge is simply the line beyond which galaxies begin flowing towards some other basin instead of ours, the way a ridge between two valleys divides the rain that falls on either side. And here is a subtlety worth holding. A structure this large is not actually bound together by its own gravity, the way a single galaxy or a small cluster is. Over the immense future of the universe, as space keeps expanding, Laniakea will not hold together as one object. Its parts will slowly be carried away from one another. It is less a building than a moment, a pattern of shared motion that we can see right now, a current caught in a single snapshot, that the expansion of the universe will eventually pull apart. We have named our home, and our home is a passing arrangement of flow. Within that flow lie our nearer neighbours, the ones we are more directly falling toward. Not far along the slope, in cosmic terms, sits the Great Virgo cluster, a rich swarm of well over 1,000 galaxies, and our own local group is being drawn toward it as part of the same larger current that carries everything toward the Great Attractor. So our motion is layered even here, at the scale of superclusters, a fall toward Virgo folded into the greater fall toward the Great Attractor, folded into the push and pull we are about to uncover. It is the same pattern we found in our own backyard, the spin inside the orbit inside the galactic plunge, now written across hundreds of millions of light years, motion within motion within motion, all the way up and all of it silent. There is a humility built into the map of Laniakea that is quietly moving. When Tully and his colleagues drew it, with its streams of flow converging like the veins of a leaf toward a single low point, our galaxy appeared on it only as a tiny dot, far out on one of the outer filaments, marked with a small label that says, in effect, you are here. Not at the centre, not at the destination, out on the rim, sliding in with everything else. For most of history we imagined ourselves at the middle of things, and every advance in astronomy has moved us further from the centre, from the Earth to the Sun to the edge of the galaxy, and now to the outer edge of a supercluster, whose true low point we are still falling toward. The map of Laniakea is the latest and largest version of that same long lesson in perspective. We are not the middle of anything, we are a drop, on the edge, in the flow. So notice how completely the meaning of your address has changed. For your whole life, if someone asked where you are, you would answer with a list of nested places, each one a thing you could in principle stand still inside, on Earth, in the solar system, in the Milky Way, in the local group, a stack of locations. But Laniakea rewrites the answer. Your truest address is not a set of places at all. It is a direction of motion, a slope you're sliding down along with 100,000 galaxies, a current in a snapshot that will not last. You do not simply sit somewhere in the universe, you're being carried through it, and the carrying is the address. So we have gone from a number to a direction to a whole basin of flow. We know how fast, about 1.3 million miles an hour. We know toward what, the Great Attractor, hidden behind our own galaxy. And now we know the shape of the current, a watershed 520 million light-years wide, with us sliding in from the edge. It would be natural to feel that the picture is complete, that we have finally answered the question and can rest. But the picture is not complete, and the part that is missing is the strangest of all. Because when astronomers looked even more carefully at why we are flowing this way, they discovered that we are not only being pulled towards something ahead of us, we are also being pushed just as hard by something behind us, and the thing pushing us is not a thing at all. It is an emptiness. Picture yourself standing in the middle of a large, slowly shifting crowd of people. If everyone around you is packed tightly on your left and thinned out, to almost nobody on your right, which way will you tend to drift as the crowd jostles and settles? You will drift toward the crowded side, pulled by the press of bodies. But notice that you could describe the very same drift the opposite way. You could say you're being pushed away from the empty side. Both descriptions point to the same motion, and that double description, a pull toward the full and a push from the empty, turns out to be exactly what is happening to our galaxy on a scale of 1 billion light-years. In the year 2017, a team of astronomers, several of the same names who mapped Laniakea, published a study with a wonderful title. They called it the Dipole Repeller. What they had done was map the flow of galaxies around us in full 3 dimensions, not just where things are, but the entire pattern of push and pull that sets our neighbourhood sliding. And they found that the story we had been telling, that we are simply falling toward the Great Attractor, was only half right. Half of our motion is indeed a pull toward dense, crowded regions ahead of us. But the other half, very nearly, is a push from behind. And the thing doing the pushing is a region of the universe that is emptier than average, a great under-dense void sitting on the opposite side of the sky from our direction of travel. Now, how can an emptiness push? Emptiness has no gravity of its own to shove anything, and the answer is a small, elegant piece of reasoning that is worth walking through slowly, because it is genuinely beautiful once it clicks. Gravity pulls in all directions at once. On any galaxy, including ours, the entire universe is tugging from every side. If the universe were perfectly even, all those tugs would cancel out and we would drift nowhere in particular. But the universe is not even. On one side of us lies more than the average amount of matter, all those crowded clusters out toward the Great Attractor and beyond. On the opposite side lies less than average, a great scooped-out region with fewer galaxies than there should be. So the tugs do not cancel. The full side outpulls the empty side, and the result is that we drift toward the crowd, which is identical to saying we are pushed away from the void. The empty region does not push with a force of its own. It pushes by failing to pull as hard as everything else, and that shortfall, that missing tug on one side, drives us forward just as surely as the crowd ahead draws us on. The team named that underdense region the dipole repeller, and they found it accounts for roughly half of our local group's motion, the very half that all the crowded regions we could see had never been quite enough to explain. For years, astronomers had noticed that the visible clusters ahead of us, the Great Attractor included, did not seem massive enough to fully account for how fast we were moving. The push from the void was the missing piece. Once you include it, the books balance. We are exhaled by an emptiness behind us and inhaled by a crowd ahead of us, and the two are almost equally responsible for our 1.3 million mile an hour journey. And the crowd ahead does not end at the Great Attractor. This is the last widening of the map. When astronomers trace the pull past the Great Attractor, they find it does not stop there. Beyond it, much farther out, lies the largest concentration of mass in our whole region of the universe, an immense supercluster of galaxies called the Shapley concentration, sitting about 650 million light-years away. The Great Attractor, it turns out, is not the final destination. It is more like a way station on a much longer slope, a local low point on the way towards something far larger and farther. The full current we're caught in, the coherent flow of galaxies all sliding the same way, stretches across more than 1 billion light-years of space, something like 1/10 of the entire radius of the observable universe. We are one drop, riding one current, in a flow so large it spans a meaningful fraction of everything we can see. Let me bring you down into that current for a moment, because I do not want this to stay as a diagram. I want you to feel it. Imagine you are the drop of water on the slope, but the slope is made of galaxies, and the valley is 500 million light-years across. Behind you, filling half the sky, is a great emptiness, a region scooped nearly hollow, and out of that emptiness you are being gently, endlessly exhaled, pushed forward by the simple fact that there is less behind you than ahead. In front of you, too far to see, lies a crowd of 100,000 galaxies and more, the Great Attractor first and the immense Shapley concentration beyond it, and that crowd is drawing you on, drop by drop, galaxy by galaxy. All around you, in every direction, other galaxies drift the same way, none of them touching, none of them feeling a thing, all of them sliding down the same silent slope. There is no wind, there is no sound, there is no sensation of speed, there is only the whole immense sheet of the universe's local structure, tilted, flowing, carrying everything you have ever known toward a distant low place at over 1 million miles an hour, in perfect, total silence. And you're lying in the middle of it, in your bed, and the water in the glass is flat. If the idea of being pushed by an emptiness still feels slippery, try one more way of seeing it, because it is worth truly owning. Imagine lying on a great rubber sheet stretched flat, and imagine heavy weights set down all across it, denser in some places, sparser in others. The sheet sags toward every weight. Now place yourself at a spot where there is a great cluster of weights off to one side and almost nothing on the other. The sheet beneath you tilts, sagging toward the crowded side, and you slide that way, not because anything shoves you, but because the surface itself leans toward the mass. The empty region does not have to push. Its emptiness is simply a place where the sheet does not sag, a high point on the tilted surface, and you roll away from the high ground toward the low. In the real universe, that sagging sheet is the gravity of everything. The high ground behind us is the great void, and we are rolling, endlessly, off its slope toward the crowd ahead. This push from the void solved a problem that had quietly bothered astronomers for years. When they added up all the visible mass in the direction we are moving, all the galaxies and clusters they could see out toward the Great Attractor, it never quite came out to enough. The crowd ahead of us by itself could not fully explain how fast we were actually going. Something was missing, some extra push that the visible matter alone could not provide. The underdense region behind us, the dipole repeller, was the missing half. Once you count both the pull of the crowd ahead and the push of the emptiness behind, the numbers finally match the motion. Our 1.3 million mile an hour drift is not a mystery of too little cause. It is the sum of two nearly equal influences, one drawing, one releasing, working together. And the scale of the whole arrangement is hard to keep in the mind. The coherent flow, the region of space where galaxies all slide the same way, caught in this same push and pull, stretches across more than 1 billion light-years. 1 billion light-years is something like 1/10 of the entire radius of the observable universe. In other words, the current we are caught in is not a small local eddy. It is a feature of a meaningful fraction of everything we can see, a slow tilt in the structure of the cosmos itself, with our galaxy and 100,000 others sliding down it together. When you picture yourself as a drop on the slope, picture the slope as reaching nearly as far as sight itself reaches. Come back down into that current one more time and hold it, because we are about to add the final, quiet twist. You, the drop of water, are sliding through the valley, exhaled by the emptiness behind, drawn by the crowd ahead, in silence, with 100,000 galaxies keeping pace all around you, none of them touching, all of them falling the same way. It feels, from inside, like nothing at all. It feels like lying still in a dark room, and it would be the perfect place to end, this vision of the great current, except that the destination at the bottom of the slope has one more secret, and it is the strangest of all the things we have found tonight. So now, at last, we have the full shape of our motion, not just a speed, 1.3 million miles an hour, not just a direction, toward the great attractor behind the veil of our own galaxy, but the whole current, pushed from an emptiness, pulled toward a crowd, sliding through a valley 1 billion light-years long toward the Shapley concentration. It is the most complete answer to how fast are we going, and toward what that the universe will give us. And it would be a satisfying place to end, a grand map finally drawn. Except for one last fact, the strangest and quietest of them all. We are never going to get there. The place we are falling toward for all the speed and all the pull is a destination we are guaranteed never to reach. Hold two images in your mind at once. The first is our galaxy, sliding toward the great attractor and the Shapley concentration at over 1 million miles an hour, a drop running down a slope 1 billion light-years long. The second is the entire universe, quietly and relentlessly expanding, every distant region drifting apart from every other, the space between the galaxies stretching a little more with every passing year. Both of these are happening at the same time, and they are in a kind of contest, and the outcome of that contest is the last and gentlest twist of the whole night. Our motion toward the great attractor is what astronomers call a peculiar velocity, which is a lovely piece of jargon that simply means our own local motion, our slide down the slope, laid on top of the overall expansion of the universe. On small scales, over distances of a few 100 million light-years, gravity is strong enough to win, and the flow is real. Our local group genuinely is drawn toward the great attractor, and nothing about the expansion changes that nearby pull. But on the larger scales, over the full billion light-year reach of the current toward Shapley, the expansion of the universe is the stronger force, and the expansion is not holding steady. It is speeding up. That acceleration was discovered in 1998, and it earned a Nobel Prize, and it remains one of the great open mysteries of physics. Something is driving the galaxies apart faster and faster, a something we cannot identify and have labelled, for lack of any better word, dark energy. We do not know what it is, but we can see exactly what it does. It stretches the space between distant structures at an ever-increasing rate, and it means that the farthest reaches of our current, the Shapley concentration, and even the great attractor itself, are being carried away from us by the expansion of space faster than our peculiar motion can ever close the gap. Think about what that means for our journey. We're moving toward the great attractor at over 1 million miles an hour, but the great attractor and the far crowd beyond it are receding from us as the universe expands, and that recession is winning. It is like walking toward a door across a floor that is stretching, the door sliding away from you faster than you can walk, no matter how fast you walk. The flow is real. The pull is real. The 1.3 million mile an hour motion is completely real. And the arrival is not. We will never reach the great attractor. We will never reach Shapley. The destination that gives our entire motion its direction is a destination the universe itself is quietly, permanently carrying out of our reach. There is a smaller, warmer exception, and it is worth saying, because it keeps this from tipping into bleakness. We're not going to lose everything. Our own local group of galaxies, the small-bound family that includes the Milky Way and the Great Andromeda Galaxy, and a few dozen smaller ones, is held together tightly enough by its own gravity that the expansion cannot tear it apart. In fact, the Milky Way and Andromeda are falling toward each other and will, in a few billion years, merge into a single larger galaxy, one that astronomers have already half-jokingly named Milkomeda. That much of our neighbourhood we get to keep. But the Great Slide, the billion-light-year current toward the Great Attractor and Shapley, the grand journey that gives our true motion its heading, that one has no arrival written at the end of it. We are bound to our small family and we're falling forever toward a horizon we will never touch. I want to let the full weight of this settle, because it is the emotional low point of the night, the moment before the turn. Consider what we have found. Your truest, fastest motion, the one real answer to how fast are you going, is a journey of over 1 million miles an hour toward a specific place, and that place is hidden behind your own galaxy so that you cannot look at it, and it is receding through the expansion of space so that you cannot reach it. Your one absolute motion points at a destination you can neither see nor arrive at. You're being carried, with enormous speed and perfect certainty of direction, towards somewhere you will never be. That is the honest end of the ladder we started climbing back in the still of your bedroom. Not a place, a direction and a speed and a horizon that keeps its distance. The force behind this is worth naming clearly, even though naming it does not mean we understand it. When astronomers measured the expansion of the universe carefully in the late 1990s, expecting to find it slowing down under the gravity of all the matter it contains, they found the opposite. The expansion is speeding up. Something is driving the galaxies apart at an ever-increasing rate, and that something makes up the majority of the entire universe, more than 2/3 of everything there is, and we have no idea what it is. We call it dark energy, which is not an explanation but a placeholder, a name draped over a mystery. What matters for our journey is only what it does. It stretches the space between distant things faster and faster, and over the immense reach of our billion light-year current, that stretching is the stronger hand. Follow it far enough into the future, and the picture grows lonelier still. As the expansion accelerates, the distant galaxies are not only failing to come closer, they are being carried away, and eventually they will recede so quickly, borne on the stretching of space itself, that their light will no longer be able to reach us at all. Over cosmic ages, one by one, the far galaxies will slip beyond the edge of what we can ever see, dropping past a horizon of light, until a future sky holds only the few galaxies gravity has managed to keep close. The Great Attractor, Shapley, the whole grand current, all of it will fade from reach, not so much by moving through space, as by having space itself stretch out endlessly between us and them. There is a warmer exception, and it keeps this from tipping into bleakness. Our own local group, the small-bound family that holds the Milky Way and the Great Andromeda Galaxy and a few dozen smaller ones, is knit together tightly enough by its own gravity that the expansion cannot pull it apart. That much we keep. In fact, the Milky Way and Andromeda are falling toward each other right now, and in a few billion years they will meet and merge into a single larger galaxy, one that astronomers have already half-fondly nicknamed Milkomeda. Our little cluster stays. It is only the Great Slide, the billion light-year journey toward the Great Attractor and Shapley, that has no arrival written at the end of it. Let the full shape of this settle, because it is the low point of the night, the moment before the turn, and it deserves to be felt honestly. Your truest, fastest, most definite motion, the one real answer to how fast are you going, is a journey of over 1 million miles an hour toward a specific place. That place is hidden behind your own galaxy, so you cannot look at it, and it is receding through the expansion of space, so you cannot reach it. Your one absolute motion points at a destination you can neither see nor arrive at. You're being carried with enormous speed and perfect certainty of direction towards somewhere you will never be. That is the honest end of the ladder we began climbing back in the stillness of your bedroom. Not a place, a speed and a direction, and a horizon that keeps its distance no matter how fast you fall toward it. And yet, and this is the turn, the one this channel always makes, because the facts permit it, and because it is true. None of this has disturbed the water in the glass. Not once through this entire journey, from the spin of the ground to the fall around the sun to the plunge through the galaxy, to the billion light-year current toward a place we will never reach, has any of it touched you. You have been lying perfectly still this whole time, and the stillness was real, and the 1,000,000 miles an hour was real, and neither one ever interrupted the other. How can both be true at once? That is the last thing left to understand, and it is the most reassuring fact of all. The reason you feel nothing is not that the speed is a lie. It is that the speed is shared, completely and perfectly by everything around you, and once you see why that makes the ride so gentle, the fear the title promised turns, very quietly, into something closer to peace. Come all the way back now, from the billion light-year current and the receding horizon, back to the small and specific place we started. The bed, the blanket with its even weight, the glass of water on the nightstand, its surface flat and calm, exactly as it was when we began. Nothing about this room has changed. What has changed is only what you know about it. And the last thing to understand is the simplest, and it is the reason the water has never once spilled. The ride is smooth because everything near you is moving with you. That is the whole secret, and it has been true at every rung of the ladder. When the ground spins you eastward faster than sound, the air spins with you, the building spins with you, the glass and the water spin with you, all together, so there is nothing to press you against and nothing to slosh. When the Earth falls around the Sun at 67,000 miles an hour, it falls as one piece, you and the air and the oceans and the water and the glass all falling together, and falling together feels exactly like rest. When the Sun carries us around the galaxy at 500,000 miles an hour, and when the whole local group sweeps through the universe at 1.3 million, it is the same story, endlessly repeated at larger and larger scale. Everything in your immediate world shares the motion perfectly. An emotion that everything shares is a motion that nothing can feel. So the stillness you feel is not an illusion in the ordinary sense, not a trick your senses play on you. It is a true and accurate report about your local world, about the relationship between you and the room and the planet, all of which are moving as one. Your body was never wrong. It was telling you correctly that nothing near you is being left behind, that there is no jolt, no shear, no relative motion to sense. It simply could not tell you about the larger motion, the shared one, because a shared motion leaves no trace on the inside. Both truths hold, without contradiction. You are perfectly still relative to your bed, and you and your bed together are moving at 1.3 million miles an hour relative to the universe. Neither one cancels the other. They were always going to be true at the same time, and this is where the word from the title, Scarier, finally shows its real shape. The scary thing was never that the speed could hurt you. It cannot. It will never touch you. The unsettling part, the thing that genuinely rearranges something in you when you first sit with it, is quieter than fear. It is that a word you trusted completely, the word still, turns out to name nothing absolute at all. There is no such thing as truly standing still. Nothing in the universe has ever done it or ever could. Still was always a comparison, a quiet agreement between you and the nearest large things, and the moment you widen your view past them, it simply dissolves. Even the cosmic background, our one great reference, is not a fixed post in empty space. It is only the average rest of all the matter and light there is, the closest the universe can come to stillness, which is not very close at all. But sit with it a little longer, past the first vertigo, and something turns. Because look at what is actually true of you, right now, tonight. You're moving faster than any machine humanity has ever built, faster than we know how to build, 1.3 million miles an hour, in a definite direction, toward the great attractor, caught in a current 1 billion light-years long, pushed by an emptiness and pulled by a crowd, aimed at a place hidden behind your own galaxy that you will never reach. All of that is happening, and you are experiencing it as the gentlest thing imaginable, as warmth, as weight, as a flat surface of water that does not tremble, as a good place to fall asleep, the most enormous motion you will ever make, and it arrives in your body as peace. That is not a contradiction to be resolved. It is the single most remarkable fact about your ordinary night, and it was hiding in plain sight the whole time. The speed and the calm are not two different things fighting each other. They are one thing, seen from two sides. You are being carried, at a speed you cannot imagine, toward a place you cannot see, and the carrying is so complete, so perfectly shared by everything around you, that it feels exactly like lying still. You do not have to choose between the wonder and the rest. You get both, at once, for free, simply by being here. You have met this exact reassurance before, on every plane you have ever flown. Picture the cabin at cruising height, 500 miles an hour over a dark ocean. A child is asleep across 2 seats. Someone is pouring coffee, and it fills the cup as neatly as it would in a kitchen. A pen rolls off a tray and drops straight to the floor, not flung toward the back of the plane, just straight down, exactly as it would at home. Everyone in that cabin is moving through the air faster than a rifle bullet, and every one of them feels perfectly still, because the whole cabin, the air inside it, the coffee, the child, the pen, all share the motion completely. That cabin is the whole story of tonight in miniature. The Earth is the cabin, the solar system is the cabin, the galaxy is the cabin, and the shared, total, silent motion of everything around you is the reason 1,000,000 miles an hour arrives in your body as rest. So the word still was never quite a lie, and it was never quite the whole truth either. It is something better than both. It is a true statement about a relationship, about you and the things nearest you, all moving as one. When you say the room is still, you are saying that nothing in it is being left behind, that you and the walls and the water are keeping perfect company, and that is completely true and always was. The word only fails when you try to stretch it past the room, out to the universe as a whole, and ask for a stillness that stands alone, with nothing to lean on. There is no such thing. But you never really needed that kind. The stillness you have is the shared kind, the companionable kind, the kind where everything close to you comes along, and that kind is real, and it is yours, and it is enough to rest inside. If you are drifting now, towards sleep, let this be the thing you carry down with you. Nothing about the speed asks anything of you. You do not have to hold on. You do not have to brace. The motion that carries you is the most reliable thing there is, older than the earth, steady as the turning sky, and it has never once, in all your life, spilled a single glass of water on a nightstand. It carried you gently through every night you have already slept, and it will carry you gently through this one. The universe is not hurling you anywhere against your will. It is holding you, and everything around you, in one smooth, shared, unbroken motion, and asking nothing of you but that you notice, if you like, and then let go. And that is the real shape of the word in the title, the one that promised something scarier than you think. The speed is scarier than you think only until you understand it, and then it becomes gentler than you ever would have guessed. What looked like being flung through the cosmos turns out to be the softest kind of carrying. What looked like the loss of solid ground turns out to be a truer and larger belonging, to a galaxy, to a current, to the whole slow flow of everything toward everything. You're not adrift. You are held, and moving, and calm, all at once. So let the question we started with come back one final time, the child's question. How fast are we going? You know the answer now, all of its layers. Over 1,000 miles an hour with the spin, 67,000 around the sun, 500,000 around the galaxy, 1.3 million through the universe, toward Hydra and Centaurus, toward the great attractor behind the veil, toward Shapley beyond it, toward a horizon forever sliding away. And you also know the other answer, the one your body has been giving all along, the one that's just as true, perfectly, completely still. Both are correct, both are yours. And the water on the nightstand is still flat, still calm, still holding its perfect level, riding with you at 1.3 million miles an hour towards something we cannot see. Rest now. You're already moving. You always were, and it has never once disturbed the water.